Ladies and gentlemen, what we're going to do is start lesson 10, where we're going to look at graphs of function in standard and factored forms. So 10.1 is going to be a linear equation and its graph. And first, this is just our warm-up question. We're going to connect some of the features of this linear equation, and then we're going to look at it later with the features of a quadratic equation. So again, here's my linear equation. We have some things. We have an x-intercept, we have a y-intercept, and we have our slope. So question 1, where do you see the 8 from the equation in the graph? So again, ladies and gentlemen, here's the 8 from the equation. And just remember, in our regular linear equation, y equals mx plus b, the number all by itself is our y-intercept. So where do you see the 8 from the equation in the graph? We could say 8 is the y-intercept, which you can kind of list in two ways. I just say here y equals 8, or you could list as a point x is 0, y is 8. So for our second question, where do you see the -2 from the equation in the graph? So here, the -2, the number times x, -2 is our slope, or we also call that our rate of change. So where is that showing up in our graph? So if I look at some points, and I could pick this point right here. So it looks like we have the point 1, 6. So what we do is we pick one point on the left. Here's another point. And for our -2, we're going to just say that -2 is the slope. And then remember, slope in a graph is a ratio of the rise to the run. So in this particular graph, to go from left to right, our rise is negative because we're going down. So here, to bring this point to the same level as that one, I went down 2. So filling in my ratio over here, we go -2 for our rise. And then here, we go over 1. So my ratio is -2 over 1, which reduces to -2. Now, we could actually pick not just one point, we could pick the ratio of the rise to run to this point. So to go from this first point right here to this third point, I go down 8 and then over 4. So we could do another rise to run, which is -8 over 4. And we can see if I reduce that, -8 divided by 4 is -2. So any 2 points on your line will give you the same slope. So for our last question, what is the x-intercept of the graph? How does this relate to the equation? Well, we see the x-intercept of the graph, it's touching at x equals 4. Or again, we could list that as an ordered pair. X is 4 and y is 0. And we could relate that to our equation. So on a graph, if I want the x-intercept, the x-intercept is where it touches the x-axis, which is actually the line y equals 0. So if I want the x-intercept, I plug in y equals 0 to the equation. And solve. So in doing so, our equation is y equals 8 minus 2x. So we're going to plug in 0 for y. So 0 equals 8 minus 2x. And then we're going to solve. So I'm going to take the 2x and move it to the other side by adding 2x to both sides. And 0 plus 2x gives me 2x equals 8. And then to get rid of the 2x, I'm going to divide both sides by 2. And then you get x equals 4. So you can substitute 0 for y and get 4 for x. So now we're going to revisit projectile motion, or quite simply just throwing stuff. So in an earlier lesson, we saw that h of t, so height at a given time, is 10 plus 78t minus 16t squared. And it can model the height of an object thrown upward at 10 feet. So again, remember 10 is our initial height. With an initial vertical velocity of 78 feet per second. So 78 is our initial velocity. And then the negative 16t squared is gravity bringing it down. So now what I would like for you to do is, with a partner or by yourself, answer 1, 2, 3, A and B. And then we will talk about the solution. So, excuse me, my expectation was a 0. So if we look at number 1, is the expression 10 plus 78t plus negative t squared in standard form? We said it is, but it needs to be reordered. So negative 16t squared plus 78t plus 10 is in standard form. And we said just simply because of t squared, or we could also think of if it's in the form ax squared plus bx plus c, a is negative 16, b is 78, c is 10, and instead of x, we're using t. So now Jada said that the equation g of t equals negative 16t minus 2 times t minus 5 also defines the same function, but in factored form. Show that she's correct using distribution or an area model. So to show my work here, I'm going to start with distribution. We have negative 16t minus 2 times t minus 5. So if I go negative 16t times t, I see that we get negative 16t squared. And then negative 16t times negative 5, we're going to add 16 times 5. I go 10 times 5 is 50. 6 times 5 is 30. So I'm going to add 80 because 50 times 30 is 80. So plus 80t. And then negative 2 times t would be minus 2t. And then negative 2 times negative 5 would be plus 10. And I notice that I'm not done. So we have the 80 minus the 2, and it gives us negative or positive 78. So the overall expression is negative 16t squared plus 78t plus 10. Now, that's one way to do that with distribution. You need to be fluid in doing distribution or an area model. So several of you like using the area model. So to model the problem with that, we have negative 16t and negative 2, and then t and negative 5. Negative 16t times t is negative 16t squared. Negative 2 times t would be minus 2t. Negative 16t times negative 5 is plus 80t. And then negative 2 times negative 5 is 10. Simplifying and collecting our terms, we get the same thing, negative 16t squared plus 78t plus 10. And I like to collect like terms here, so inside. So I did negative 16t squared. I saw we have two t terms, 80 and then minus 2. 80 minus 2 is 78t, and then bring the 10 out. So now we have a graph of both on here, and they represented the same thing. So identify the vertical and horizontal intercepts. So the vertical intercept is just another word for our y-intercept. And you can write y-intercepts in a couple ways. The approximate y-intercept is y equals 10. Or you could also list that as a point. X is 0 at the y-intercept, so you would have 0, 10. And then your x-intercept is at the point x equals 5. And then we could list that where we have the x-coordinate is 5 and the y-coordinate is 0. So now we have to put that a meaning to that in terms of our initial height and how long it took the object to hit the ground. So the y-intercept is our initial height. So our initial height is 10. And looking back at the problem, we're measuring in feet. So the y-intercept, y equals 10 or 0, 10. And let me label that as a y-intercept. Just means the object is thrown from 10 feet. And then if we look also at the x-intercept or the horizontal intercept, so that just means x equals 5 or the point 5, 0. And again, that's 5 seconds and 0 feet. So the object hits the ground after 5 seconds. So in going back to our problem, I like to make sure that we know here it's 5 and 0. However, we have a real world application. So this 5 means 5 seconds and 0 feet. But even saying it's 5 seconds and 0 feet, we have to further clarify what that means. So 0 feet means the ball is, or the object is at the ground. And then the 5 would mean after 5 seconds. Okay, so as we look at this, it says factor the standard form of the function to find factored form of the function. In factored form, set both the equations equal to 0 and solve the resulting equation. So what we're going to look for are some key points, the x-intercepts, the y-intercepts, the rate of change, and the zeros. So in looking at this, we have to identify this as standard form or factored form. So again, here, this is standard form. And I want to show you how from standard form you could get factored form. So to make our area model here, our area model is an easy way of factoring this. So I know that x squared would go in the top left. And I know my constant term 3 has to go in the bottom. Now I'm going to split up this 4x between here and here, but I don't know how. So to do that, what you do is you have x here and x here. And then we have to look at what things could we multiply to make 3. And the only factors of 3 that we could put on the outside are 1 and 3. So we look outside here, and you can see x plus 1 is going to be right here. And x plus 3 is going to be right here. Now, a couple things that I want you to notice. We have two x-intercepts right here and right here. So we have x-intercepts at x equals 3, x equals negative 3, and also x equals negative 1. I'm going to show you how to find the x-intercepts, or find, those are also called zeros. So again, our x-intercepts and zeros, different way of saying the same thing. Now, I don't want you to have to create a graph every time to find them. I'm going to show you how to take this equation from factored form and solve. So first of all, here's what you do. We have x plus 3 and x plus 1. If I want to find the x-intercepts, that's when y equals 0. So instead of putting this in function form where we write y equals x plus 3 times x plus 1, we plug in 0. Now, if two things multiply to be 0, both of them could be 0. So what you do from there is set both equal to 0 and solve. So I'm going to do my work over here. And up here too, to bring this out, this is how you find your x-intercepts. So what you do is you say, I have x plus 3 equals 0, and I have x plus 1 equals 0, and you solve both of those things. So subtracting 3 from both sides of this equation, plus 3 and minus 3 cancel out, and we can see directly from the equation in factored form, our first x-intercept, or 0, is negative 3. And then if I'm solving x plus 1 equals 0, subtract 1 from both sides, and you would get x equals negative 1. So we can see having a graph is an easy way to visualize the x-intercepts or zeros. You can also do so directly from the factored form of the equation. Now, to get the y-intercept, we don't do that directly from factored form. We can actually use standard form. So the y-intercept is a number by itself in standard form. So our y-intercept is y equals 3. Or you could list that as a point, 0 for x and 3 for y. So again, you can find that on the graph here. It's crossing at y equals 3, and then you can list it as a coordinate 0, 3. So what I want for you to do is fill in the rest of these, finding those points with a partner.